Welcome to Investigating the Universe. Today we embark on a profound exploration that delves into the very heart of existence. Our journey takes us on a quest to unravel one of the most enduring mysteries that has puzzled the greatest minds throughout history. We pose a question so simple yet so complex, it shakes the very core of our understanding of reality. The question is this: can something come from nothing? The concept of nothing is not as straightforward as it may seem. It's a topic that straddles the border between philosophy and science, between reality and the abstract. It's a question that has been asked for centuries, by philosophers, theologians, and scientists alike. As we venture into this exploration, we will delve into the realms of metaphysics and cosmology, where the abstract meets the tangible, and where our understanding of the universe is both questioned and expanded. To contemplate this, we enter the realms of metaphysics and cosmology. In the domain of cosmology, we explore the beginnings of the universe. Cosmology, derived from the Greek roots cosmos meaning universe and logos meaning study, is the scientific endeavor to understand the large-scale structure and history of the universe. It is a field that weaves together the threads of astronomy, physics, and philosophy to unravel the cosmic tapestry of existence. Our current understanding of the universe's origins is largely based on two significant theories: the Big Bang Theory and the concept of cosmic inflation. The Big Bang Theory, first proposed in the early 20th century, posits that the universe began as a hot, dense point nearly 14 billion years ago. It suggests that the universe has been expanding ever since, transforming from a state of unimaginable heat and density into the vast expanse of galaxies, stars, and planets we observe today. But how does this relate to the idea of something coming from nothing? Well, it's a tricky question. The Big Bang Theory doesn't necessarily explain what sparked the initial expansion, or what, if anything, was present before the event. It simply provides a mathematical model for the universe's evolution from a tiny fraction of a second after that point. On the other hand, the concept of cosmic inflation proposed by physicist Alan Guth in the late 20th century provides a potential answer to these questions. It suggests that the universe underwent a rapid exponential expansion in the fractions of a second following the Big Bang, driven by a kind of repulsive gravitational force generated by quantum fluctuations. Some cosmologists even speculate that these fluctuations could create an endless series of universes, a concept known as the multiverse. So while these theories provide us with incredible insights into the origins and structure of the universe, they also leave us with profound questions. What caused the Big Bang? What was there before it? Can something truly come from nothing? We examine the notion of a finite origin for our cosmos, and we continue to seek answers to these fundamental questions. Our journey ventures into the quantum realm, where the laws of physics take intriguing turns. Quantum physics, unlike classical physics, allows for seemingly impossible events to occur. This is where we stumble upon the concept of quantum fluctuations. In the simplest terms, quantum fluctuations are temporary changes in the amount of energy in a point in space, as allowed by the Heisenberg's uncertainty principle. This principle, foundational in quantum mechanics, states we can never simultaneously know the exact position and momentum of a particle. This uncertainty allows for particles and antiparticles, a particle and its opposite, to spontaneously form and annihilate each other. This might sound like a magic trick, but it's a routine phenomenon at the quantum level. These particles, known as virtual particles, pop in and out of existence in such brief moments that they're almost ghost-like. Yet their effects can be observed and measured. But how does this tie into our question about the nature of nothing? In classical terms, a vacuum is a space devoid of matter, essentially nothing. However, in the quantum world, a vacuum is a bubbling, busy place where particles and antiparticles are continuously forming and annihilating. This suggests that nothing, at least in the quantum sense, is full of these temporary, spontaneous happenings. Quantum fluctuations in the vacuum challenge the notion of nothing, as particles seemingly emerge spontaneously from empty space. To grasp the philosophical significance, we turn to thinkers through the ages. The contemplation of nothingness and its relation to existence has been a cornerstone of philosophical inquiry since time immemorial. Pondering this profound question, we journey through the annals of human thought, where the concept of nothing has been examined, redefined, and debated. The ancient Greeks, led by thinkers such as Parmenides and Aristotle, considered nothing to be an impossibility. For them, nothing was not just the absence of something, but a state that could not exist. Parmenides famously declared that nothing comes from nothing, while Aristotle argued for a world that has always existed, negating the need for creation out of nothing. Fast forward to the modern era, where philosophers like Martin Heidegger and Jean-Paul Sartre have recontextualized nothing within existentialism. For them, nothingness is not just a philosophical concept, but a fundamental aspect of human existence and individual freedom. And yet, despite centuries of discourse, the question remains as elusive as ever. Can something truly emerge from nothing? Or does nothing as we understand it even exist? These quandaries continue to perplex us, driving us to delve deeper into the enigma of existence. The great philosophers, from Aristotle to Parmenides, have contemplated the nature of existence and nothingness, paving the way for modern debates. As we continue our journey, we carry their insights with us, lighting our path towards understanding the universe. Religious traditions also weigh in. The question, can something come from nothing, is not just a scientific or philosophical quandary, but a theological one as well. Different religions across the world have divergent views on the creation of the universe. In many religious beliefs, the universe is not self-originating, but rather a divine creation. The concept of ex nihilo, or out of nothing, is a common theme, suggesting that the universe was created by a divine entity from a state of absolute nothingness. For instance, in Christianity, the book of Genesis describes God creating the heavens and the earth from a formless void. This aligns with the ex nihilo concept. Similar narratives exist in other religions like Islam and Judaism. On the other hand, some Eastern philosophies propose a self-originating universe, where existence emerges not from an external creator, but from the inherent properties of the cosmos itself. For example, in certain interpretations of Hindu cosmology, the universe goes through endless cycles of creation, preservation, and destruction, all through natural processes. These varying perspectives demonstrate that the question of something coming from nothing has far-reaching implications, not just in science and philosophy, but in the realm of spiritual beliefs as well. The question of divine creation versus self-originating universes has profound implications in theology and belief systems. In the contemporary scientific landscape, we grapple with theories like the quantum vacuum, which challenge traditional concepts of nothing. We're riding the crest of a wave of discovery, where the lines between something and nothing are redrawn, reshaped, and reimagined. Consider the quantum vacuum, a state devoid of traditional particles and energy, yet brimming with potentiality. It's a realm of ephemeral particles, popping in and out of existence, creating a seething froth at the very fabric of reality. Here, nothing is, paradoxically, something. Then there's the realm of cosmological models, where a universe could spring into existence from the quantum vacuum, a transition from nothing to something that doesn't require a supernatural hand. It's a bold idea currently beyond our empirical grasp, but within the realm of theoretical physics. Meanwhile, the field of string theory offers a different perspective where multiple universes could exist, each with their own physical laws, shaped by cosmic evolution. Here, the notion of nothing is transformed into a cosmic landscape teeming with potential universes. These are just glimpses of the intriguing theories that push the boundaries of our understanding. They challenge us to redefine nothing, to question our preconceptions, and to embrace a universe that is far more mysterious and wonderful than we ever imagined. But the quest for ultimate answers continues. As we push forward, we continue to question, to explore, and to marvel at the enigma that is our universe. As we conclude our voyage, we stand at the threshold of an enigma that persists. We've ventured through the realms of cosmology, delved into the quantum realm, wrestled with philosophical musings, and navigated theological conundrums. We've grappled with the origins of the universe, the concept of cosmic inflation, and the enigmatic quantum fluctuations. All these explorations have led us back to the central question that has captivated and confounded thinkers throughout history. Can something truly come from nothing? This question, simple in its form yet profound in its implications, remains largely unanswered. It challenges our understanding of existence and non-existence, of causality and spontaneity. It urges us to reconsider what we perceive as nothing. As we continue our cosmic quest, this question will guide our explorations, encouraging us to push the boundaries of our understanding. Can something truly arise from nothing? The pursuit of an answer continues to inspire our journey into the mysteries of the universe.